So we have how many people? Okay, good size. Last time we talked about the general structure of the course. We talked how we are gonna grade it. We talked what books we are gonna study, and then we started talking about C++, why we are studying C++. And today we are gonna do our chapter number 1 from the textbook, Savage book. And we are gonna see our first C++ program, and we are gonna compile it, and we are gonna look at some basic stuff. Some of them you already know, some of them might be a little bit new. Okay, so any questions from last lecture? Any questions from last lecture? I guess there are no questions. Then maybe I should ask a question in this case. As I said, from time to time I will pick people and I will ask questions. Let me pick okay. Berkcan Ekici, Berkcan. Okay. Tell me, what language is the most popular right now among the employees? Berkcan. Berkcan Ekici. So tell me which language is the most popular language right now, this year and last year? Use your microphone. As I said before, everybody should have a working microphone. If you have a computer to attend this class, computers have microphones, I know. Okay? Bekcan, could you turn your microphone on? I am not hearing you.
Hocam rahat konuşamıyorum da evde, o yüzden.
You're gonna just say C, Java, C++, just one word. No,
C.
it is not C. Berkcan, it is not C. You did not attend the last class?
C++.
No, it is not.
Java.
Okay, yeah, it is correct. It is Java. So you did not attend the last class?
Evet hocam, katılamadım özel
Just
sebebiyle.
talk in English. If you did not attend the class, okay, if you did not attend the class, then watch the videos. That's why we are recording the videos and making it available, okay?
Okay.
Okay, you may miss it from time to time. Yeah, I understand it, but you before coming to the class, just watch the video, and I spent maybe 10 minutes to talk on this. And from now on, I think I will start my lectures, or in the middle of the lectures, I will ask these kind of questions so that people come to. Okay. I looked at my attendance, if it is correct. Okay, so last time we looked at it, and today we are gonna see our first. C++ program. Okay. Oh, come on. Okay. We are gonna do introduction to C++. Then we are gonna look at this variables, expressions, and assignment statements. You all know about these from your 102, and then console input output, program style and libraries, etc. Some of them will make sense. Some of them will. You may think that this is not how it's supposed to be, but it will be okay in a few weeks if you don't understand some of the stuff, and it will be okay. So the introduction to C++, C++ as a language, Okay, it emerged at the end of 1980s. Okay, end of 80s. Okay, and it is built on top of C programming language. C programming language. Okay, so here we say that it is built on top of C programming language, but it's a completely new design philosophy because it uses these object-oriented programming language principles. Okay, object-oriented programming language principles. And as I said before, object-oriented programming language principles are the main things that we are trying to learn in this course, CSE241. We say that there are high-level programming languages, there are low-level programming languages, and the best example for the low-level programming language is the machine language and assembly language. So what is the difference between machine language and the assembly language? Can anybody tell me?
Readability.
Assembly is more readable, right? But I am talking about the way about the structure. What is the main structure difference between machine language and the assembly language?
Machine language contains only 1 and 0.
Yeah, sure. You may say that too. Machine language contains only numbers. It doesn't have to be binary. It is usually written in hexadecimal format. The language is something like FABA0107 something like that. Okay. So this is not understandable by humans if you are not very experienced with that CPU. Assembly language is more like load to my register the number 7. Okay, something like that. Okay, then you add 17 to register B, something like this. So it is more readable. Again, it is readable, but it is not as convenient as some of the other languages, because writing programs in assembly, debugging them, trying to understand them is not easy. That's why they invented these high-level languages. High-level languages are more like they are more compatible with the human thinking. In this case, you would say things like, okay, I have a variable named sum, and I will increase the sum by this amount. I will print the value of sum to the screen, etc. Okay, they are not as convenient as human languages like Turkish or English, but still they are much better than machine or assembly languages. And C++ is one of the high-level languages. C is another example. So in terms of high-level, low-level stuff, C and C++ are in the same class. Okay. Within these high-level programming languages, okay, we have different type of philosophies. One of them says that there are functional languages. Okay, I think you have seen some of the examples of these functional languages, like Lisp is a very good example. Some of them are imperative languages. Okay, and we have object-oriented programming languages. Do you know the last one? Lisp is a good example for this one. For imperative programming languages, C is a good one. C++ is a good example for object-oriented programming languages. Do you know the last category? Anybody has any ideas?
Generic programming.
What is that again?
Generic programming.
I don't know what generic programming is. But it is not. It is declarative. The best example for this one is Prolog. Usually the imperative and declarative is just the opposite. In imperative programming languages, you just put statements one after the other. Okay. You say that do this and this and this and this and this. In declarative programming languages, you don't specify your algorithm. Okay. You just tell things like the facts. Okay. I know this and I know this and I know this and I know this, and at the end you ask a new question. How about this? Okay. So declarative programming languages, an example is Prolog. So the most popular ones are nowadays object-oriented programming languages and imperative and functional. And in fact, some languages, they combine all together, like Python. Python uses both functional paradigm, imperative paradigm, and object-oriented programming paradigm. Okay. So still, we talk about object-oriented programming languages, but we don't know what it is. And it will be clearer as the semester progresses. Okay, so let's go back to C++ again. Okay, today I will not talk much about object-oriented programming languages other than this. Instead, we are going to look at the structure of a C++ program. C++ programs, okay, are very similar to C programs. So for C programs, you do this. You have a, let's say, a file. Let's say the file name is test.c. Inside this file, you have this main function. You have to have a main function, right? And you might have other functions, as many as you like. Okay, and this is how you write your C programs. The C programs are basically built on top of functions. Okay, you write functions and you call functions from each other. Okay, this is how you do it. C++ programs are very similar. You have to have one main function. If you are going to run your program, you have to have your one main function. Okay, let me try to draw another one here. This is test.cpp. Okay, you have to have this main function. You may have, if you like, other helper functions. Okay, and on top of it, you have class definitions. Class, let's say A. Okay, so C++, the main structure of the C++ programs are like this, and we are going to see one example. The example is will be very similar to this example, but for now we are not going to see any class definitions. Okay, so let's look at the program. This is our first program. Just read it a little bit and you will understand some of the statements. Some of the statements will make sense, some of them will not. Total of 16 lines. Total of 16 lines. And as I said before, it has one main function. It returns an integer. Okay, here is the integer being returned. And then at the beginning, like in C, I have an include statement. Okay, this is a preprocessor statement. Okay, this is a preprocessor statement. And preprocessor statements are different from C statements, right? And we'll talk about it later. You have never seen a header file like this IO stream before, right? Usually for printf and scanf, what did we use? What kind of header file did we use? What did we include for the printf?
stdio.
stdio, right? In C++, we don't use stdio. Instead, we have a very similar header file named IOStream. Okay, the second line is new. Okay, using namespace std. And for now, let's ignore this line, the second line. Let's ignore it. The third line is our main function. A main function should have a body, and the body is between line 4 and 16. Number 5 is number of languages. Okay, so we are declaring a new integer. Integer declarations, double float declarations are exactly the same as C. 6 and 7, we did not see this before. This is not available in C. And as you may have guessed, it prints this statement on the screen. It prints on the screen, it says that, hello reader, a new line, then welcome to C++. Okay, so if I like to write the same thing in C, I would write this. Printf %s, okay, and %s, and then hello reader \n, comma, welcome to C++ and \n. I think I messed it up a little bit. Let me try to fit this in like that. \n, and that's it. So this is what you would write if you like to do the same thing in C instead of C++. In C++, we don't use printf. Printf is available, but we don't use it. We use this operator, stream insertion operator. This is called a, okay, stream insertion operator. As the name says, it's an operator. Okay, it's an operator. So let me ask you this question. What is an operator? Can anybody tell me what an operator is? Just give me an example for an operator. An example for an operator. I gave you one example, stream insertion operator, but you did not know this operator, but you know many other operators.
AND operator.
AND operator, logical AND, right? So
Yes, sure.
this one is an operator. This is a logical AND, and this one is bitwise AND, right? This is logical AND. This is bitwise AND. This one takes two Boolean parameters. This one takes integers. More common operators, plus, minus. Okay. So the operator is like a function. Operator is like a function. Okay. It takes one or two or three parameters. It does something and it returns you something else. Let's take it to this example, plus. Plus, let's say it takes two integers. Okay. It adds the value of these two integers and it returns 5, right? So operators are like this. Operators, they take parameters, one or two parameters, sometimes three parameters, very rare, but it happens, and it returns a value. Okay. So tell me an operator that takes a single parameter. An operator that takes only a single parameter, not two. Minus takes two. Okay. Plus takes two. this one takes 2 and this one takes 2. So usually most of the time it is just 2 parameters, but sometimes there are operators that takes only a single parameter. Which one is that? Or which ones are there?
Not operator.
Well, that's a very good answer. Yes, sure. Yes, not operator. You will say not A equals B. This one is going to return a Boolean, and you will take the not. Or when I said, remember this one, I said that minus takes two parameters, right? But there are 2 types of minuses. This one takes single 2 parameters, but this one takes, okay, this one takes, this minus, it will take single parameter, just 7. Okay, so minus is a special one. It will take both 2 parameters and a single parameter. Okay, so let's go back to this line number 6 and 7. Okay, so this operator is going to take a string. You know what string is from C, and it takes another parameter. We don't know what this parameter is. Okay, and this one is an object, and it represents the standard output. Object. Okay, I'm simplifying lots of stuff. So it takes a object named cout. It's like a variable, like number of languages a variable. This one you may think it like a variable, okay, but it has some values. Okay, it will take an object, cout object, and it will take a string. So what did plus do when I say 5 plus 3? Plus said that I will add these together and I will return a new one for you. Okay, 8, I will return an 8. So what does the operator do? It takes a string, it takes a standard output, it prints the string on the screen, and it should return something. Okay, okay, this part here, this part, it should return something, because all the operators, they return something. Okay, this one will return the exact same object that it took. It will return cout. Okay, it returns cout, and now I can do, okay, I can do this stream insertion operation again. Line 6 and 7 is no different than this arithmetic statement. Okay, you add 5 and 3, it will return 8, another integer, and I add 8 and 1, it will return 9. Okay, and I'm doing the same thing. This operator takes 2 parameters, it does something, it prints something on the screen, and it returns the cout itself. Now I am evaluating this part. Okay, so 6 and 7 work like that. So what did we see in 6 and 7? We have seen stream insertion operator, a new operator for us, and we have seen the cout object. Okay. Cout object represents the standard output. Okay, whatever you send to standard output, if you didn't do anything else, okay, it will be printed on the screen. So this is what it does. Then line 8, it says that how many programming languages have you used? A question. Okay, another print statement. Then we have this line number 9, cin, and just like stream insertion operator, but this time is stream extraction operator. Okay, this is stream extraction operator. And cin, like cout, it is connected to standard input. Okay, so this one says that read me an integer from the keyboard. So the corresponding C code would be scanf and %d, comma, number of languages. Okay. So somebody is, I don't know why people are not asking me a direct question. I mean, I missed that part. I mean, just ask a question. Elif Nur has a question. She says that, sir, we use \n for end of line, but some examples use end of line. Elif Nur, we did not come to that part yet. When we come to that part, I will tell you the difference. There is no difference. Kahraman has a nice comment. He says that we should add an ampersand here. What happens if you add an ampersand? What happens if I miss this address of operator? By the way, this is an address of operator. It's an operator, okay? And it takes a single parameter. It takes a single parameter and it returns the address of that parameter, right? So, Kahraman, you said that we should add an ampersand. What happens if I miss that ampersand? Would my program compile? I am not going to read your messages. Just tell me in person. Would my program compile?
Yes.
Okay, yes is the correct answer. But it would not give me anything useful, right? When I compile and run, I will be in trouble. Okay, I will be in trouble. Usually, my program is going to crash when it executes this line. Why? Because if the initial value of number of languages is 0, since scanf needs an address, instead of sending an address, I am sending a value of 0. So the scanf will think that the address is 0. 0 means null, yeah, right? Null is the address of nothing. So scanf is going to crash because there is no such address. The operating system will stop my program from working. Just try this. I am sure you have tried this. And you have failed many times. You have wondered what's happening. It is compiling, but it's not running. So this is how you learn a programming language, actually. You don't learn programming languages from the box. You don't learn your programming languages from your professor, okay? You learn them yourself by making these kind of errors. So line number 9, it does exactly the same as that scanf statement. But the thing is that, see, as you see, we did not tell the compiler that I need to read an integer, right? I just said that, okay, just extract me an integer from the keyboard. How does the compiler know that it is going to get an integer from the keyboard? It knows because number of languages is an integer, okay? So C++ is a strongly typed language. Okay, so C++ is a strongly typed language, and it uses this type information a lot. C doesn't care about especially the original C, the classical C, doesn't care about the types of the parameters, the types of the variables, and etc. much. That's why you could say, instead of number of languages here, let's say I have a float here, float my f, and its initial value is 1.0. okay, instead of saying address of a number of languages, my f, and this line still compiles, right? This line still compiles. Even though I say that I am going to read an integer, here is an address of an integer, but I am sending the address of a float. No problem. This will compile, but don't expect anything useful out of this line. Right? So this is a bad line. And the compiler will not help you to catch this error. In C++, these kind of errors are more rare because I am not telling the compiler what kind of data I am going to read. Okay? The compiler already knows that it's an integer, so I am going to read an integer. Okay? Any questions so far? Okay, any questions? So let's continue if there are no questions. And line number 10, number of languages, if there is an if statement. If the number of languages is less than 1, that means it is 0, right? Then it says that, okay, read the preface. You may prefer a more elementary book by the same author. If the number of languages is 1 or greater, then it says that enjoy the book. It's a very simple program, stupid simple program, and I could have written the exact same program in C, okay, and I could have done a better job because I like printfs and scanfs better. Some C people like them better, okay. But this is how you write programs in C++. By the way, I did not use much object-oriented programming techniques here. I have a single function. I did not write any classes. This is just to demonstrate how a C++ program is written. Gökbey has a question. He said that if I understand correctly, stream insertion operator takes a string. How can we scan or print an integer? Gökbey, you did not understand it right. As you see, this one takes an integer. Okay, I could have put a float in there too. Same with stream insertion operator. You could print out anything you like. See out a string and then an integer and then maybe a float, my float, and then maybe a character. All of them are possible. Okay, all of them are possible. How can we scan or print it? Okay, so again, C++ is a strongly typed language. Since it claims to be a strongly typed language, we don't like these kind of statements in C++ because these type of statements, they let the programmer control the types, not the compiler. But if I do this, okay, the compiler knows the type. It knows that this stream insertion operator is going to work on a string, okay, on a string. By the way, this line, let me use the blue, cout 7 and cout 7.0, these two stream insertion operators are not the same. They are very different. Okay, it is very similar to this statement, and these statements are very, very different statements. This plus operator takes two integers. This plus operator takes two doubles. Okay, addition operation for integers and addition operation for doubles are so different. How do you represent a double in your memory, and how do you represent a integer, unsigned integer in your memory is very different. For example, to represent this one, what do you have? Let's say I have 32 bits of words, so there are positions for 32 bits, and the first one is a, oh, this is so bad. Okay, okay, this is 1, these are all zeros, right? There are 32 of them. Okay, this just represents 1. How do you represent 2? Just the corresponding thing. But how do you represent a 1.0? How do you represent a 1.0? You have this, you know this from 102 course, right? You have exponent and mantissa. Okay, that's why we call the floating point number. You use this exponent part and mantissa part, and you express your floats using the exponent and mantissa parts. And each one is a binary representation, but usually this is much more complex than this one. So the addition operator for the floats or doubles are very different than addition for the integers. Again, stream insertion for 7 is very different than stream insertion for 7.0. Okay, Emine says that we can say that operators are functions. You could say that operators are specialized functions, right? That's true. Atakan says yes. I don't know why he says yes, but I think he's answering something else. Okay. Yes, Emine, operators are specialized functions. Why do I say specialized? Because functions can take any number of parameters, including 0, 1, 2, 3, 4, 5, 6. Okay. Operators, they take parameters, only 1 parameter, 2 parameters, and sometimes 3 parameters. Okay, and nothing else. These are operators. Okay, functions are more general. In fact, I mean, in C, you didn't need any operators, right? In C++. Why do I need this operator? If I had a function like this, it returns an integer. Its name is add integer, and it will take 2 integers. Okay, to be able to do the same thing, I would call this add integer with 1 and 2, right? Instead of writing it this way, I would just call a function. You might say that, okay, how about this? What am I gonna do this? If I like to do this kind of compound function calling, then in that case, what would you do? You would do this. Let me, okay, sorry. Let me take this part a little bit down. Okay, so what would you do? You would say add integer, comma 3, right? Okay, so you don't, actually we didn't need any operators in C or C++. So why do we have things like this? I mean, this is okay, right? I mean, instead of saying 1 plus 2 plus 3, 1 plus 2 plus 3, I could have said add integer, parentheses, add integer, parentheses 1, comma 2, parentheses and 3, right? So I could have obtained the same result. So why do I need the operators? Question. Why do we need the operators then? Somebody tell me in person, don't write it, okay? Use your microphone. Why do we need the operators?
It's simply just a lot easier.
Say it again.
It's just easy.
It is just easy to write and read, right? It is
Yeah.
difficult to read this one, but this is so convenient to write. Operators are for human readability. That's why we have it. We didn't need any operators. Remember this operator takes the address of an integer. In A, I could have said address of int A. No problem. it give me the address of something. Okay, so these kind of things are done for human readability. Okay, and we are doing the same thing here. Instead of calling a function printf and scanf, let's use a new operator. Okay, stream insertion operator. By the way, when I say new, these two operators are not new to C++. They are already in C. Do you know what these are? This one and this one. These two are available in C, but we don't call them stream insertion.
Bitwise operations.
Bitwise what? Bitwise?
Bitwise shifting.
Yeah, bitwise left shift and right shift. If you take, for example, the number 2, if you shift it 2 times, okay, so it is bitwise shift. Let's say 0, 0, 1, 0. This is 2, right? If you shift it 2 times to the left, okay, it becomes 1, 0, 0, 0. So every time if you shift something to the left, you multiply it by 2. Okay, if you shift something to the right, you multiply it by, you divide it by 2. Okay. Okay, good. Okay, so the thing is that, I mean, we had these two operators in C. Now we are adding a new meaning to these functions, to these operators. I mean, this left shift and right shift didn't go away. They are still available. Okay, they are still available. But now we are adding new meanings to these operators. It's called operator overloading. Operator overloading. Okay, operator overloading. What is operator overloading? Actually, we did this before. Like, it is the same thing as this example. In C, they have already overloaded the plus operator, so it works with both integers and doubles. These are two different operators. They are overloaded and we have been using them. Okay, and now they have overloaded these two operators so that it works with the stream insertion extraction and also for bitwise left shift and right shift. Okay, so Hussein Ömer has a very nice question. It's a very good question. In the function, okay, he says that, how am I going to implement this addend? Just implement this addend. Inside the addend, I had to use the plus operator, right? How am I going to add 2 integers? Okay, what would be your answer? Can anybody have an answer for this?
Can we use recursion functions?
Can we use what?
Recursion.
To add 2 integers?
Yes.
Just explain it a little bit.
At the end of the function, we can say return 0 or 1 until it reaches them. We can return the original function.
How does that add 2 integers? I don't understand how it does add 2 integers.
I'm just asking, sir.
Hussein is asking, in that case, inside the implementation of this add int, wouldn't I have to use the plus operator? How am I going to add 2 integers? And I am asking the same question to you guys. How would you add 2 integers if you don't have the plus operator?
In the end, at the back of everything, plus operator is doing some assembly code, like it's running in registers. So
Yes.
maybe we can do the same thing with the function. I mean, plus operators in the end is a somewhat function that's kind of shorthanded.
Yeah, exactly. I mean, somebody has implemented this plus operator, right? It's a function. Somebody has implemented it. Whatever the code it is, we can do the same thing. How would you add 2 integers? Let's say this is my Let's say my bits are 8 bits. This is 1, and I am going to add it with this one. How would you add these two? You will say, let's make it a little bit more complicated. Let's add 3 with 2. So how would you do this? 1 plus 0 is 1. 1 plus 1 is 0. 1 carry, 1 here, and this. So the result is 5. Okay. You can implement this algorithm. How would you implement it? You would use in C bitwise operators. Okay, bitwise operators. I think I would do this. Every time, okay, let's say A, I get the AND A and 1. Okay, let's say this is A and this is B. What is A and 1? This is bitwise AND. You did not see bitwise operators in C? Bitwise AND, bitwise OR, bitwise NOT?
We saw it.
You saw it. Okay, what is A and 1 in this case? A is this. Okay. A and 1 is 1, right? Because I am ending. Okay. Let me do it this way then. Let me use just 4 bits. This is A. This is 1. If you take the bitwise AND, 1 and 1 is 1, 0, 0, 0, right? A or 1 is, what is A or 1?
Again 1.
No, A or 1 is, it is 3, right? Because this one is going to be 1, this one is going to be 1 again, 0 and 0. So my algorithm would be this. Take A and 1, take B and 1, so you would get the last binary digits here. Last binary digits. Do your operation that way. And then right shift both numbers A and B just once, right shift. When you right shift them, okay, the second digit will be your last digit. And do this operation until you are done with all the bits. Okay, this is an exercise for you. Okay, and this exercise is credited to Hüseyin Ömer Güray, since he asked the question. Okay, exercise. Okay. Implement unsigned int add int unsigned int and unsigned int. Implement this function by Monday.
Okay, sir.
Okay. It is up to you. Of course, you should not use the plus operator. Okay, don't use the plus operator. Okay. Well, I mean, usually it is not implemented. This is a simple operation. This is not implemented this way because there are already assembly instructions, machine CPU instructions available to add 2 integers. Okay. CPU, you know the CPU, right? CPUs are sophisticated enough to add 2 integers. Okay. All you do is load A to a register, load B to another register, okay, and you execute this instruction, add A and B. Okay, this is how it is done. This is how it is done. But if you don't want to use the CPU stuff, just implement everything in C, then implement this algorithm and we will see how it works. And maybe some of you understood why I say these are unsigned integers, because representing the minus sign is a little bit tricky. I don't want to get into that trouble. Okay, good. I think we have questions. In the C language, overloading doesn't available. So how does operator overloading works in Atakan? That's a very good question. The answer is you don't. In C, you don't have operator overloading. Okay. Gökbey says that can we create operators like we create functions, common division operator, etc. Gökbey, we have a complete section, like 50 pages, about operator overloading. Okay, hold on to that function until we get to that chapter. But the short answer to this your question is operator overloading doesn't create new operators. You only overload available ones. Okay. Whatever is available, plus, minus, division, ampersand, star, what else? Address operator, etc. These are all AND operator, logical AND operator, binary and bitwise AND operator. These are all available for you to overload. And we will see them when we come to that part. Okay, good. So I still 16 lines of code, and I have written lots of stuff. I still did not compile this, and I am out of time. Let's take 10 minutes of break. It is now 9:23. Let's be here 9:33. Okay. So we'll be back at 9:33. Efendim. Buyurun. Teşekkürler. İyi günler. Okay, people, let's continue. So this is our first C++ program. Let's compile this. How are we gonna compile this program? Of course, we are gonna use our G++ compiler. We are gonna say G++ compile. Let's say my program name is hello.cpp. Okay, and this one will produce me an object code, hello.o, right? So this one will produce me hello.o if I don't have any compilers. And once I have the hello.o, I can link it to produce my executable program. So what would I say? G++ minus o produce, my output is going to be hello, and you're gonna link this program hello.o. So this will produce me an hello. Then I would run this. Okay, I would run this saying that I like to execute this one. This is very similar to what you did with C. You compile, you link, and you run. Okay, you compile and you link and you run. Do you know how many computer engineers in Turkey are there who doesn't know what compiler is? You will be, what percentage of the Turkish computer engineers doesn't know what compiler is? Do you know this number? Just take a guess.
50?
Yeah, it is around 50. Yeah, around 50 of them. When I ask them what is a compiler, they say we don't know. They have never compiled the code, or even if they compiled it, they did not know what they are doing because they are not using this command line structure. Okay, they are using Visual Studio or some kind of a development environment, and and this is happening when we do the interviews for our graduate admissions, for yüksek lisans alımları, okay, they are all computer engineers, right? I like to ask them, what is the difference between compiler and the linker? Very simple question. But I cannot come to that question because they don't know what compiler is. Okay, 50, it is 50, Yunus Emre. Half of them they don't know. And even if they say they know, they don't know the difference between the compiler and the linker. Okay, that's why we like you to go to the basics, and we don't teach you Python. Okay, if you teach you Python, then you wouldn't know what compiler is, because with the Python environment, you just type something and it gives you an answer. You just type something and it gives you an answer. You cannot differentiate what is the terminal, what is console, what is input, what is output, who is doing what. You just try something and it gives you something else. Try something, it gives you something else, and you keep doing this until you get whatever you want. Okay, they call it programming. Of course, it is not. Okay, so let me go to my console, and here I have my program hello.cpp, and if I type it, you will see it is exactly the same. I copy it from the book. Let's compile this. G++ -c hello.cpp. It is compiling, and it came back with no messages. That means that it compiled. So I have my hello.o. Now I can produce an output executable file, hello, and hello. Come on. Let me mute this. Okay, hello.o. It linked. Now I have an executable program. Hello. Okay. I know it is executable because it says it is XX. What's going on? This funny thing here. These are all wrong. Ch mode O minus X hello CPP. Okay, good. Okay, so this executable thing, hello, okay, it is executable, and now I'm going to execute it. How do I execute it? This way. Hello reader, welcome to C++. How many programming languages have you used? I would say 0. It says that read the preface. You are not good for this class. But if I say I know 10 languages, it says that enjoy the book. Okay, this is basically how you compile it and how you run it. Okay, I think on yesterday, our TA Ilhan went over the same process to tell you how to compile programs. In fact, he showed you how you use development environments, integrated development environments, such as Eclipse, NetBeans, and Visual Studio, maybe. I don't know. As a professional engineer programmer, of course, you should not compile your programs this way. I mean, using the console, because this is too primitive. But to be able to understand what is going on with the compiler and the linker, you should definitely know how the things are done here. Okay, if you use, let's say, Eclipse is doing the same thing. Okay, when you compile a program, it just calls the G++ compiler with the necessary switches, and say that I'm compiling, I'm linking, and etc. Okay, so what kind of switches did we use now? We use, let's look at the switches. Compiler and linker options. These are the switches. -C is for compiling, -O for outputting, right? -C and -O. Do you know any other compiler switches? Do you know any other compiler switches? Okay, minus S. People know about minus S. Okay, that's very good. Okay, minus capital S. What is minus S? It produces the assembly, right? Oh, you learned it yesterday. Okay, good. You know about the G. G is for debugging information. S is for the producing the assembly stuff. How about minus E? Do you know what minus E is? I ask a question and I wait for you to type. Why don't you use your microphones?
It is used not to compile, but to link to compiled files or something like that.
No. Oh, STD. Okay, STD is good. STD is another one. STD C++11, for example. That's good. Okay, but how about minus E? To be able to know what those options are, you do this. You read the manual page of G++. Man and G++. And it will give you this large document that says that these are the popular, see, these are the, can I do this? Okay, good. These are the popular command line options. Minus C we already know. Minus S we already know. Minus E we are going to look at it. G here, okay. STD is here, okay. And these are for the include directories and the linking directories. This minus D is a very nice feature. Minus O we already know, okay. So these are a few switches. G++ is much more complex than this. There are literally hundreds, maybe 1,000 switch available for G++. And let me show you those. Okay, these are overall options. These are C language options. These are C++ language options. These are Objective C++ options. Then the warning options. Then the debugging options and optimization options. Program instrumentation options. Processor options. Okay. Assembler options. And it goes like this and this. And how many pages, I don't know. And different kind of architectures, different options. Nobody is expected to know all the options of G++, but you should be familiar with the common ones, like minus S and etc. Okay, and these are the file types, and okay, X, it's a C is here, S is here. This is E. What does E do? It's a very good one. You know, Hussein did the exercise and he pasted the code, but unfortunately it is not indentation is messed up. If A return B, and okay, good. So you are doing with a while loop. Try doing it with a recursion function. Okay, this is good. You are getting it. Does it work? Did you test it? But Hussein, this one works for all the integers. I ask you to do it for the unsigned ones. Test this using with negative integers. It will
Okay.
not work. Okay, so while you are at it, maybe just solve the signed problem too. So just if it is a signed integer, then if it's a negative, then turn it to positive and run this algorithm and turn it back to, understand what I mean? Okay, let's look at this minus E. Minus E is a very nice option. It says that stop after the preprocessing. What does the preprocessor do? What does the preprocessor do? Somebody tell me, what does the preprocessor do? We have the compiler, we have the preprocessor. Compiler is different from preprocessor. What does the preprocessor do? It handles, let me show you my program again. let me show you my program again. It handles the, okay, Emirhan, very good. Replace macros and constant, not globals, no. Preprocessor only handles, okay, preprocessor directives. So if a line starts with a sharp sign, like an include statement, okay, or define statement, or a macro definition, okay, preprocessor handles it, not the globals. Globals are different. Globals are handled by the compiler, okay. Globals are handled by the compiler, but the defines are different than the globals. Okay, so include IO stream. So what does the processor do when it sees include IO stream? Okay, if I do this, compile hello.cpp, but stop after the preprocessor. Do it again. I need to redirect it. So I don't know how to redirect. Where is my? Oh, okay, here it is. Is this? Yeah, okay, I found it. Okay. Hello to hello prep.cpp. So it compiled it. Now I have this hello prep cpp. What do you think hello prep cpp has? What do you think this? He's saying come back to class. Do this after the class. What are you doing? He's fixated on the exercise. So what does this hello prep.cpp include? Look at the size. What is the size? WC minus L is hello prep cpp. There are 28,000 lines. What is the original cpp? Original cpp is just 20 lines.
It will replace the include with the whole library.
Exactly. Whatever was inside that IO stream header, it is pasted into this hello prep.cpp. Let's look at it a little bit. Let's hello prep cpp. So my program became like this. Okay. Many things that I don't know. Let me try to open it with a better editor. Okay. At the beginning, lots of preprocessor directives again. Okay. And let me try to go, okay. A namespace definition and inline definitions. You don't know many of them. I did not see anything that I can recognize as a C programmer. Okay, let me go to the last line. The last line is this. Okay, here's my program. Did you see this? So it pasted all of those 28,000 lines before my program, and after that my program is here. So how do I compile this? You just compile it G++ -C hello prep cpp, and it compiled it. Okay, hello prep .o is there, and when I link it, it will run. Okay, so when I am compiling this 16 lines of code, actually I am compiling 28,000 lines of code. Okay, 28,000 lines of code, because with that include, there are many things coming. Remember when I said this? Okay, like cout is an object, is like a variable. Same with number of languages. Number of languages is defined at line 5, but cout has to be defined somewhere. It is defined inside this IO stream. Let's go there and try to find where that IO stream, that cout is defined. If I can find it, let me see. Sometimes it is difficult to find it. Okay. Where is my, okay, cout. Oh, it's going to be difficult. Why? Because there are, okay, here it is. Here it is, line number 28 144. It says that it's an external thing, it's an O stream. See, its type is not integer, its type is O stream. So there is a new type named O stream. And Cin is an I stream, C error and C log are O streams. So they are all defined in here. They are all defined in here. Okay. I think inside this IO stream I have, somebody was asking about this end line, right? End line. Here it is, the definition of end of line. It is in here. There are many versions of it. It is overloaded, I guess. Most of the time we don't understand what's going on, but this is what is the meaning of minus E. But you told me that you already know what minus S is. Let's compile our program with a minus S. CPP minus S. Okay, what do we have? hello.s. Here it is. And let's look at what is inside this hello.s. It's an assembly file. Okay, my file is hello cpp. Different sections. These are labels. Okay, this is the address for the hello reader, address for the welcome to C++ string addresses. There are some alignment stuff, but our main program is like this main program. Okay, okay, these are all calling some functions. See, it loads the value of this LC0 and then, yeah, okay, and it makes this call. It makes a call to this function. Okay, I guess that function is responsible for printing stuff. But in my program, it looks like this LC0 and LC1 are part of the same statement. It looks like compiler divided into two different function calls, assembly function calls. Okay, one call is here. This is one for hello, and this one is welcome to C++, another call. Okay, where is the if statement? Do you guys see the if statement? Yeah, L2, see? It makes a comparison here, test L. If it is one way, go to L2, otherwise go to L3, something like that. Okay, so this one is printing LC5, this one is printing LC4 and 3. So if is happening here. And at the end, I make a return. It is a little bit complicated because the assembly for the I processor, Intel I processor, are much more complicated than the assembly that you have seen for the CSE102. Okay, CSE102. Okay, let me make a small, very small experiment. Copy hello CPP to add CPP, and let me make a modification and see. I am trying to I try to understand how okay A comma B comma C. Let me, okay, assignments. A is 2, and C is A plus B. Okay, and let me change it with 6. Okay, 2 plus 6 I am trying to calculate. Let me print this out. Oh no. Ooh, okay. CW and A. C out. C. Very simple program. Let me compile this one. G plus plus, what was the add.cpp? It works. Let me run it. Yeah, it printed 8 here, right here. Since I did not use the new line, it didn't give me a new line. So it works. My thing is I don't want to compile it actually. I like to get the assembly for this one. And let's look at this add.s, how the addition operator is implemented. Okay. So this is move 2 to A, move 6 to B, and take these two to my two registers, ADX and EDX and EAX, and add these two and put the result into -4 C, right? And move this number to EAX again and print it out. So the question, the answer to your question, original question, I don't remember who asked this question. How am I going to do the addition? Addition is done this way. I mean, it is not done the way Hussein did it in a few minutes ago. Okay. It is just directly addition to the addition instruction to the CPU. If I change this to floats, the code will be very, very different. It will not be the same. It will not be the same. Oh, maybe let's not do that way. CW, these are all integers. Okay. And 7YY and copy it that way. And how am I gonna do this? No. It's X insert A. If I compile it this way, I will get a compilation error. But if I put this in a block like that, and it will be okay. 1, 2, 3, 4, 5, 6, 7. No. 7. Good. I couldn't get the... Okay, good. So this will compile. And I'm going to make this a float or double maybe. And since these are double, these should be insert 0, dot 0, and dot 0, dot 0. Okay. Let's compile this. And let's look at the assembly again. So this is first add L, okay, and it makes a call to the printout. And then I have the rest. This is add SD, okay. So these are very different. Why? Because the adding two integers is very different than adding two doubles. Again, I am still using the CPU instructions. I am not implementing anything to add it to numbers myself. Look at these numbers, minus 16s and 24s, and so it looks like the size of the double is a little bit 36 and 32. Do you know what 36 and 32 means? Does anybody can make a guess? Can anybody make a guess? 30 minus 32 and minus 36. It says that move to something minus 36. You get the stack pointer, okay? You decrement it by 36 and you put it in there, okay? And I am doing the same thing here. So the difference between these two is just 4, but the difference between these two is 8. So the size of the double is much larger. That's what I'm saying. Okay, do these kind of experiments yourself. Read the compiler manual page. Okay, read the compiler manual page. There are many nice options in there. Nobody is going to tell you all the compiler options. You are supposed to find them yourself. Okay, let me show you this nice feature, and let me stop in here because I don't want to go on and on. Remember we have the define statements. Okay, let me do this. Define number 6.0. Okay, so let me, instead of saying 6.0 here, so okay, if I do this, the result of my program will not change, right? I will get exactly the same thing. I will get 8.0. Is that correct? If I compile and run this, let me get rid of these integers. If I compile and run this, I will get 8.0. There would be no difference. I just made this num 6.0. Okay, and let me compile it. G++ add.cpp. Okay, and run it. It says 8. Why? No, well, what happened? Why did I get add.cpp? Didn't I? Why didn't I get? These are all doubles. Okay, let me make it this way. So it is doing this. I was expecting point something. Now I will get it. 8.1. Okay, so it works fine. How about this? I come here and I delete this line. No defines there. Okay, no defines there. And what happens if I compile this? Just give me an answer. What happens if I compile this one? G++ add.cpp. I just erase that definition, define line.
Error.
I think it won't compile.
It won't compile it. It will give me an error, something like, I don't know what num is, right? It says that num was not declared. I don't know, because I previously I defined it and I deleted it. There is an option in C++, G++. You may define your defines at the command line, like define num, and if I can find the equals thing, okay, 6.0 or just 6. See? So what did I do? I can do my defines and undefines at the command line without changing the code. And if I run it, I will get the exact same result, 8.1. And this is one other preprocessor options. So this could be useful sometime. Why? Because you will say that, let's say in your code you have, if define debug, then do this. If not define debug, then do this. You may say that define debug and 1. Okay. If you do it, if you compile it this way, you are defining your debug flag, and your compiler will be your code will be compiled using the debug flag on. Okay, so without changing your code. Okay, without changing your code. Sometimes you don't want to change your code because that code might be used, that file might be used by some of your team members. Okay, if you are working on the same file, 5 people at the same time, you don't want to change that file, okay, because other people will get affected. So you can, if you like to compile that code with the debug flag on, then you would do it this way. Again, there are many nice things like these with the G++ documentation. Just read the documentation. Okay, let me go back to my slides again. So it looks like I spent like 2 hours for these. I did not spend any time on this one. I did not spend any time on this one. A little bit on this slide and a little bit on this slide. So 2 hours on 2 slides. It's not going very fast, but it will be much faster after this point. We are trying to make some point right now, and I'm trying to make you ask questions. We'll be going faster. Okay, let's continue if there are no questions. Are there any questions? I guess Hussein did this for unsigned. Return A, return B. Okay, so Hussein did the recursion, and I did the G++ manual page. Good. Okay. So this is the output of the program. I did not talk much about object-oriented programming in this program. Okay. All I said was this is how C++ compiler works. Okay. We did not talk much about object-oriented programming other than saying this. C++ is a strongly typed language. All the object-oriented programming languages are strongly typed. In fact, you will not find any language other than the assembly machine code that behaves like C. C doesn't care about the types. It says that you are the boss, programmer is the boss. Whatever you want me to do, I will do it. If you like to compile your code without this ampersand, I will compile it. You told me so. Okay. G++ says that no. I am a strongly typed language, and type is important. I will use the type information. I will help you that. Okay, Mohammed has a question. Mohammed, if you don't ask question, you're using your microphone, I will not see them. Okay? Ask me that question using your microphone. He says that can we use formatting with the cout? Yeah. It is not as convenient as printf, and we will see a few examples in a few minutes. Okay, so in C++ variables and identifiers, the idea of identifier is the same as C. In C, we use identifiers for functions. Where do we use the identifiers? For functions, right? For variables, for struct names, right? What else? There are many places that we use identifiers. The same is valid for C++. We should have identifiers like the in Turkish kimlik, identity. Okay. Identifiers has a special structure. Like in C, all the identifiers has to be case sensitive. Okay. no identifier can start with a numeral. This is a good identifier, okay, but this is not a good identifier. This is okay, this is bad, because no identifier can start with a numeral. Usually, we ask you to use meaningful names for the identifiers, okay. This is a good meaningful identifier name. Number of languages. When I read it, I know what it is. Okay, when I look at it, I know what it is. But identifiers like alpha 1 is not a good identifier. I don't know what it is. I don't know what it is. So when you read the identifier name, you should be able to understand what it is going to be used for. When you use a for loop, we usually do things like int I from 0 to I less than size, etc. It is okay to use a variable named identifier named I in here, because I and J and K are usually used for indexing in loops. This is meaningful because it is accepted, everybody knows it. So whatever identifier you are using, of course, your identifiers should be case sensitive, you know that. They should be valid, and they should be meaningful names. They should have meaningful names. Of course, identifiers are different from the keywords or the reserved words. Okay, let me do this. Okay. What are the keywords, reserved words in this example? Tell me the reserved words or keywords in this program.
Using namespace.
Using is a keyword. Namespace is a keyword. Int is a keyword. How about main? Is main a reserved word or what? How about C in and C out? Are those reserved words?
They're from standard library.
They are from standard library, and if I don't use the standard library here, C language or C++ language doesn't know what they are actually, right? So they are not reserved words. But if you end up using standard library, then you have no way of reusing them. At least no easy way of reusing them. Okay, so C out and C in and same as main, they are not reserved words, they are identifiers. I cannot use them because if I have a variable named main, integer main 5, okay, that's not a good idea because that will create confusion with the main function. Okay, so those are the differences between the identifiers and reserved keywords. And now the idea of variable is the same. Okay, idea of the variable is the same. When you say to the compiler, I have an integer named size and its initial value is 10. Okay, this is a variable declaration. You are telling the compiler that whatever the size of integer, okay, is, I need that much space in memory. So find me a space in memory of size integer and put this number 10 in it. Okay, this is what you are doing with the variable. Variables have names, variables has values, and variables has memory locations. The type of the variable depends on you. You define it. The initial value or the value of the variable, again, you do it. Name of the variable, again, you decide it. But the memory position of the variable is decided by the compiler. Okay, is decided by the compiler. It is not easy to change the position of the variable in your memory. Of course, if you like to know the position of that integer, you may do this. Just do this: cout okay, cout address of size, it will print the position of the size in your memory, and it might change from time to time. Okay, because every time size might be at a different place when you compile your program, when you run your program. Because you don't make that decision, compiler makes that decision. But every time you run this code, cout size, it will print 10, right? Why? Because I initialized it with the value of 10. How about this? How about this? What would this print on the screen?
Garbage.
Exactly. Undefined, unknown value. But let me tell you, most of the time, 99% of the time, it will print 0. But you are not guaranteed to get 0 all the time because you did not initialize that size variable, and you are printing something that you did not initialize. So you don't know what is at the position of variable name size. Okay, but usually it is 0. Usually it is 0, but it might change from compilation to compilation, from run to run, from machine to machine, and from time to time. It will print 0 all the time for you as a developer, but when you deliver the code to your customer, it might print -7013. Okay, this is initialization problem, and this happens a lot with the C and C++ programmers. We should be careful about this. Some languages, they say that this is an uninitialized value. Okay, they will warn you or they will give you a compiler error. In C or C++, this is perfectly valid code, but it's a bad code. It's a compilable code, but it's a bad code. Okay, so the book says that some of the types, most of them are common with C and their sizes. But okay, this is display 1.2. At the end of this display, the book also says this. This is a very important. Okay, or maybe this one too. It says that long double is 10 bytes. Long double will take 10 bytes in your memory. So the value that it can represent is a very small. Okay, this one too very large. It's a very close to 0 value, right? 10 to the power minus like 5,000. And this one is 10 to the power like minus plus 5,000. Very small value, very close to 0. This is a very large value. Of course, I can make them negative too. So it can keep 19 digits in it. Okay, 19 decimal digits.
Can long double be minus, sir?
Excuse me?
Long double numbers can be minus?
Sure, yeah. I mean, you could put a minus in front and minus in front here too. For the doubles, there is no unsigned doubles. Okay, for the integers, there are unsigned ones. But when saying it is 10 bytes, it depends on your system. I mean, it depends on your processor type, operating system type, your compiler, and etc. Okay? It doesn't have to be 10 bytes all the time. Let's say for the next generation of CPUs, instead of 64-bit CPUs, let's say we have 128-bit CPUs. Long doubles in that case could be 20 bytes. For some embedded systems, let's say I have a 16-bit embedded system, the compiler might say that my doubles are 4 bytes. Okay, here doubles are 8 bytes. Some systems may say that my doubles are 4 bytes because my CPU supports it that way. So these numbers are just for give you an idea. But if you like to know what kind of double size you have on your system, on your program, what would you do? What would you do? How would you learn the size of double or integer on your system, on your programs? How would you know the size of your integer in your program?
Size of function.
Size of is not a function, it's an operator, but the answer is correct. Burak, size of is not a function, it's an operator. Okay? You would do this, right? Size of int. It's like a -8, right? Size of int. I don't use any parentheses. If I use the parentheses, then you would say that, well, it's a function. But I don't have to use the parentheses. Of course, I can use the parentheses like this or that, but I don't have to. Size of is an operator. The difference is important because if size of is an operator, then maybe I can overload it, right? It will come later. Okay, so when you say cout size of int, it will print usually 4. But when I was an undergrad student like you, during those days integers were like 2 bytes, like the short. Nowadays, most of the integers are 4 bytes and 8 bytes. Just test it on your system. Okay, but if you like to make sure that your bytes is going to be okay, your integers, okay, 1 byte or 2 byte integers or 4 byte integers or 8 byte integers, then you may use these. Okay, these are C++ 11 fixed width integer types. These are guaranteed to have this many bytes. But as I said before, these are supported by C++ 11. Okay, C++ 11. Let's take the int32t. I am out of time, sorry. But let's do this and then I will stop. Vi add cpp. Let's make this int 32t abc, and this one, let's compile this. Okay, add.cpp. Oh, but did I erase that num? No, I did not, right? Will it compile? No, okay. Let me do this. And it compiled and it should run. But I was surprised that it ran, it compiled, because I was expecting that I would get an error message because I did not use the C++ 11. I should have used -std C++ 11. It looks like my compiler's default version is C++ 11. That's why it did not give me an error message. That's what I'm guessing. Okay, so these are additions of C++ 11. If you like to use them, then use it that way, but you are supposed to use the C++ 11 flag. Okay, that's it for today. Are there any questions? I am out of time. I used 5 more minutes than I was supposed to. I am sorry for that. Well, I am not that much sorry, but yeah, that's how I say.
I have a question
Yes, sure.
about Monday class.
About what class?
Monday.
Okay.
İlhan ay tutuldu.
Do I have?
İlhan ay tutuldu class.
Well, on Monday I will do the class, and on Tuesday again. For the first weeks, maybe 3-4 weeks, I am doing all the classes, all 3 of them, Monday, Tuesday, and Wednesday. Okay. After that, once we have enough material to do the problem sessions, either Ilhan or Mehmet will do the PS. Okay.
Okay, but 2 days ago, İlhan Aytutlu say something about virtual machine and the editor that we should
But
use.
on Monday we did not do any class. We did not do any lectures on Monday. He did it yesterday.
Yesterday, sorry, it was yesterday.
Okay. So what's your question?
He said you should use virtual machine that I submit on Moodle,
Yeah.
and you should use Eclipse editor. The question is, what will happen when we don't use virtual machine and the Eclipse editor?
Well, I went over this yesterday. Did you attend yesterday's class? I told you that
Yes,
we don't
but,
care. We don't care how you compile your program, how you develop your program, what kind of editor you are using. But before submitting your programs, you should compile your program using the command line compilation method on our virtual machine to make sure that whatever you are compiling is the same thing that you are going to compile. If your compiler and our compiler is different when we are grading your homeworks, then we will not try to fix your errors. Okay? So you should always compile your homeworks before submitting with the virtual machine using the G++ compiler. That's what I said yesterday. And that's what Ilhan must have said yesterday. Okay?
Okay.
Yeah, for the summer projects, Yunus Emre, summer projects, I think we will make an entry in our Moodle page so that you can submit your summer projects, and you're gonna make a demo next week. So by this Friday, you're gonna make your submission to the Moodle page about the summer projects. It will be homework number 0 for you, so it will be an bonus project for those of you who did this summer project during the summer. Murat, I don't know what you mean by YouTube channel, but yes, I have a YouTube channel. I uploaded the material that I recorded yesterday, and it is available. All you do is you just go to my channel. To go to my channel, you just type my name here, YSAKGUL, okay? And if you go there, okay, if you go there, so the uploads are there. So I uploaded just one thing yesterday, okay, 21 hours ago, and it is this class. So already 91 people watched it, and 2 people are excited about it. Okay, so the video is there, and you can, if you like, you can watch these videos. Of course, I mean, if you did not attend the class, you should watch these videos. And if you like, you could watch my videos from last year. All you need to do is go to videos, okay, and make a search, fall 2019 CSE241. Okay, see, this is from last year, October 18th. It is there. And during those days, we used to have students in class. Okay, see, it is all there. So if you like to
Can I-
watch them, just watch them.
Can I ask something?
Sure.
Is the virtual machine is the guaranteed way not for homeworks? For example, we write a code and it doesn't run on another computer. Is the virtual machine is most guaranteed way?
Yeah, true. I mean, if you, whatever you do, whatever you compile and run on the virtual machine, it should be exactly the same as our virtual machine, unless you are doing something like this. If you don't initialize your data, the result that you get might be different than the result what we get, because it might print 0 for you and it might print -5 for us. Okay, if you don't have these kind of problems, then the result should be exactly the same. Okay,
Thanks.
of course there are some compiler switches. Sometimes you will say that I use this compiler switch and this and that, and you should tell us how you compiled your programs. Okay, thanks everybody. That's it for today.